So, in the previous class, we were discussing about the cost function of the logistic regression, and all these algorithms of ML do have a cost function. Okay, and what's the role of cost function to identify the error? Okay, and we need to improve the working of the algorithm. That means error should be reduced. Then only we are going to get the good accuracy of the model. Here, in case of logistic regression, we do have a different cost function than the linear regression. Okay, so in previous class also I did told that cost function is an sum of, that means it will take the average of the loss functions. Okay, so if I do talk about deep learning, there we do have iterations. Okay, and at every iteration we are having losses. Okay, if we find the average loss, then it will be called as a cost function. The definition of this cost function I have already told in the previous class also. Here it's clear that cost function is a function that measures the performance of a machine learning model. So we are checking the performance. That means ultimately, if the error is less, performance is good, and if the error is more, performance is less. Okay, so the calculation of error. We have done the calculation of error in linear regression also. Okay, so as per I told that loss function is an error for individual data points. Okay, and cost function is the average of the error of n sample in the data. Okay, so whatever be you're going to take the, if you're going to take the n samples, so overall it's a cost function, and for individual data points, okay, individual data, then it's called as a loss function for the logistic regression. Okay, we were studying about this thing, and I do mention that linear regression cost function is not applicable on logistic regression, because we have seen one graph related to the logistic regression. Okay, and this graph is having too many local minima, and our goal is not to have any of a local minima. Actually, I want a global local minima, because I need to perform gradient descent means I need to go down to find the minimum point. That will be the place where my error will be less. That's my goal is. Okay, so the above graph, this graph we have seen in the last lecture also has many local minima, which takes it very much hard for the cost function to reach the global minima and to minimize the error. Okay, so we need to do this thing. That's why we are not using the cost function as we do for the linear regression. The case is something different. Here is what the graph between error and the cost function. You can see that there are many local minima. If I believe that this is my minima, local minima, if I say okay, I got the local minima, and still you can see that error is more. Okay, if I do select this particular point, you can see error is more. I want to reach this particular point where error is less than the previous error. Okay, you can see that E2 is less than E1. So that's what I want to achieve. As much as error is less now, obviously your performance of the model is good. So here error is more, here also error is more, and I want to reach at that particular place where error is less. So I need to reach this particular goal, that is my global minimum. Okay, so these are the two equations which we have seen in the previous class. That is, the cost function for the logistic regression is given as cost h theta x comma y is equal to minus log of h theta x when value of y is equal to 1, and this thing is minus log of 1 minus h theta x when value of y is equal to 0. This is the cost function for the logistic regression. Okay, and we have seen the generalized equation also for the cost function. What was the generalized equation? Here it is. This is a generalized equation for the cost function. Okay, where your y is your actual output and h theta x is your predictions. And here is what you got the result: minus y log of h theta x minus 1 minus y log of 1 minus h theta x. Now the question prevails. Now the question prevails, which I do asked in the previous lecture also, how to prove this thing. how to get this statement, how to get this equation. That's what we want to work upon. So let me share my complete screen, then we can have some discussion over it. I'm sharing my complete screen, then we can check out how we approached to this particular equation. Fine. Hmm. In logistic regression, the cost function is typically defined as a negative log likelihood. Negative log likelihood, which is also known as cross entropy loss. Cross entropy loss. Okay, so negative likelihood. What it means, we are going to see ahead. So ultimately, the goal of cost function is to measure how well the model is performing. That's the deal. Okay, and we need to find the optimal solution. That means we need to adjust weight and bias in such a way that it will result in the minimum of the cost. This thing we have also seen in linear regression. We did adjusted the weight and the bias only, and we tried to minimize the costs. That's the deal. Okay, so here is the equation for the cost function. We have seen in the previous lecture also, that is minus 1 by m multiplication summation y into log hx plus 1 minus y log of 1 minus hx. Okay, and here j theta is your cost function. J theta is your cost function. Okay, m, you very well know, it's the number of data points. Okay, that is the number of training examples. Y is your actual target, that is either 0 or 1, because we know that logistic regression works on a classification problem. And hx, okay, hx is the predicted probabilities. You very well know that in case of logistic regression, we are going to achieve the probabilities. We give the input, we get the probabilities, and we need to distribute these probabilities into classes. That's what our task is in case of logistic regression. Okay, so hx is the predicted probability that output is 1 given as the input is x, and the current parameter h theta x is given by this equation. This is what the sigmoid function is. You know, this is sigmoid function. So your logistic or logit is a sigmoid function only. All right, and we have seen in our initial stages of study of logistic regression that this is your, okay, axis, and we see that this is your sigmoid function. Okay, that means between 0 and 1, it has a value between 0 and 1. Okay, so if there is a line, because it was logistic regression also comes under a family of linear models. It comes under a family of linear models. Okay, however, it's a classification algorithm. Okay, and its values, you can see that it ranges from 0 to 1, this class. Okay, so this is your sigmoid function or logit function, sigmoid or logit. Okay, this line is y equal to mx plus c, and you have seen that sigmoid function is given as f. You can see f of x, for example, 1 upon 1 plus e की power minus I can take b naught plus b1x, b1 b naught plus b1x. This is your sigmoid function. Okay, else case, you know that there is a way to represent this thing. There is a way. What's the way? In case of linear regression also, we have represented this thing in the form of like beta naught plus beta 1x plus beta 2 x2 है ना, x1 इसको x1 and so on. Okay, similarly we can represent here it in the form of multiplication of theta into x. This is how they represent the power, e to the power, in form of theta x. So we can write it as f of x is equal to 1 upon 1 plus e की power minus theta x. That's what we can write in case of sigmoid function. Okay, so yeah, here it is. Here it is. They mentioned e की power minus theta x. Okay, so the cost function measure the difference between predicted probabilities hx and the actual target labels. So predicted probability and the actual target label, that is the difference it will calculate. Okay, because your target is 0 and 1, it's a classification, and the prediction which you are doing is a probability. You're performing predicted probabilities, so that is hx. Okay, and then according to that I need to put this thing into this theta hx, so that it will give me the result whether it is what 0 or 1, whatever it is. Okay, so I'm going to map with the label that you gave 0, actual was 1, you gave 1, actual was 0. Then later on we called it as confusion matrix. Okay, when your predicted is 0, actual was 1, that means your model was confused between them. Okay, or when your predicted was 1, actual was 0, again that's a confusion, so it's called as a confusion matrix. That's what we say, na? True positive, false negative, false positive, true negative. Okay, so here calculation of probabilities has been done, and it has been mapped with the target 0 and 1. So when the predicted probabilities are closer to the actual target level, the cost function will be low. Obviously, error will be less. If your predictions are closer to the output, that means error is less, and you say that it's a good fit model. Okay, and when the predicted probabilities are deviating from the actual labels, that means the cost function will be high, and obviously your model is working poor. Okay, so the goal of the training in the logistic regression model is to find the good fit. Okay, that's what we want to do. We want to find the values of the parameter theta, and we want to minimize the cost function j theta. We now want to minimize this thing j theta. This is the cost function, we want to minimize it. Okay, so how we can do this thing? What is the chance of doing this? Let me talk further. Let's talk about the equation first. How we got that particular formula? Let's get started. In logistic regression, the hypothesis function or the sigmoid function is given by hx equal to 1 plus 1 upon e की power minus theta x. And how we got this particular formula? What's the reason of getting this formula? We have already studied in our initial classes that you are having probabilities here. You are having probability. For example, p is the probability of success, so 1 minus p is the probability of failure, because it's already told in case of logistic regression we are going to predict the probabilities. Okay, so p is for success, 1 minus p is for failure. Then we have calculated odds. We have calculated odds. So odds for success is given by p upon 1 minus p, that is the ratio of success to the failure, and odds of failure is given by 1 minus p upon p. That's what we have calculated. Okay, and then according to the logit function we did calculated the log of odds. Log of odds, so log of p upon 1 minus p. We have seen this thing, and this should be equal to what? Your equation. What is the equation? What's the equation? Your line equation. Fine, so I can have anything in here as a parameter. Okay, a naught plus a1x, for example, a naught plus a1x. Okay, so if this is to the base e, log to the base e, so if I just change the formula, that means p1 minus p, this is equal to e की power a naught plus a1x, है ना? According to the property of log and all these things. So I just brought this thing into power. I need to solve for p. I need to solve this thing for p. So let me bring this 1 minus 1 upon e की power a naught plus a1x equal to 1 minus p upon p. This is what I can do. Okay, and then I can separate the from the denominator 1 upon e की power a naught plus a1 x equal to 1 upon p minus 1. Let's bring this 1 here. Okay, let's bring this 1 here. So it will be, if I'm going to bring this 1 here, so it will be like 1 upon e की power, let us assume theta x plus 1 equal to 1 upon p, and your p, just take the ratio, so it will be 1 plus theta x upon okay, don't take the ratio, don't take the ratio. Okay, don't take it, the ratio. I will, okay, it's better you can,
So we will cross multiply.
no, no, nothing, no need to do, don't do anything. Okay, just let me take this to the power, and then we can have a later on we can have a cross. So let me have. Okay, just do this thing
Yeah.
to the
In
power.
this
It
in the
will be
previous
e
step,
ki power minus theta x. Yes, Bhishma. Yes, you are right. Okay, so I can take this thing to the power, n plus 1 equal to 1 upon p, and let me cross multiply here p and bring this thing down. So p equal to 1 upon 1 plus e ki power minus theta x. That's it. This is your value of p.
yes,
That's what we have done. And from here the things get started. This is your sigmoid function, and this is the way how to derive a sigmoid function, starting from the probability. So this is the probability. That's what I need to calculate. I need to calculate the probabilities. Now this is something which I need to calculate in case of logistic regression. So our solutions get started from here. Okay, we need to get start from here. Hx equal to 1 upon 1 plus e exponential minus theta x, where hx is the predicted probability. This is your predicted probability that the output is 1, the given input, and the current parameters theta. Theta represents the parameters. Theta is the parameters. So what are the parameters? See, in case of your linear regression also, we are having parameters. Okay, in case of linear regression, you know that we do write y equal to mx plus c. So the parameters are m and c because the value of x is same. Here also minus theta x, the value of x will be same. I am looking forward for the theta to solve. Okay, so this theta thing is something which we need to solve. Okay, so obviously it's a multiplication, and there also same thing. In multiplication was there. If you are having a doubts or theta, your writings are theta x or what it is. If you remember, if you do remember, we can have a matrix like this. Okay, and one matrix like this. I hope if you remember this thing. So we can have a theta 1, theta 2, theta 3, theta 4. We can have x1, x2,
yes, and dot
x3,
product.
dot product, this ka, then plus this ka, then plus this ka. है ना? And that's what we called as a theta x. And in my previous lectures, I already told about this thing. One thing can be done. Na? This can be in front. That's it. It's a dot product. So I can take the dot product of the coefficients and the variables. That's what theta is. That's what here also theta is. That's why I've written e ki power minus theta x. So it's our sigmoid function. Now what can be done next? It's a predicted probability. Now, what I need to do next? What's the case? So let us consider something. Let us consider a binary classification problem. So this is a basic problem which every classification algorithm says that we are perfect in performing the classification. Okay, so binary classification is something everyone is confident. So we are also taking the same problem statement. In case of binary classification, you know that the target is your target is 0 and 1. Okay, your target is 0 and 1. So we need to predict the probabilities, and we need to map it with 0 and 1. Okay, so the thing is, the probability of y being 1, you can have the two values for y. You can have two values. Either y is 0 or either the y is 1, because it's a binary classification problem. None other than these, only 0 and 1. So these are the outputs. These are the actual outputs, 0 and 1. And what is your sigmoid function? Your sigmoid function hx is 1 upon 1 plus e ki power minus theta x. I hope everyone know about this thing now. And these are your actual targets. Okay, now what can be done over it? So they are saying when uh, when y equal to 1, that means it can be written as hx when y equal to 1 and 1 minus hx when y equal to 0. That's what they are saying. Okay, because we are having what hx. If we do consider that our function, our cost function hx is equal to, that means if I do consider only this thing hx for y equal to 1, so for y equal to 0, what should be h of x? It will be 1 minus h of x. Why? Because the reason is the probability lies between 0 and 1. If this is a probability, if you are saying that hx is the probability when the value of y is equal to 1, so what is the probability when y equal to 0? It will be 1 minus h of x. ये पॉइंट क्लियर हुआ या नहीं, whether this point is cleared or not. This is your cost function, no? You said, sir, we are
Clear,
talking
clear,
about the
sir.
sigmoid. Okay. And I need to solve this thing to bring that particular cost function equation. Okay, so they are saying that you are going to calculate the probability now. Okay, fine. Let us assume that my actual output is 1, and at that particular time your predicted probability is hx. So what will be your predicted probability when my values of y is 0? It will be 1 minus hx. It's quite clear. ये तो it's quite simple understanding. Then what will happen next? What they are saying? They are saying that the likelihood of the observed data, that is the training set, is the product of the probabilities of all individual data points. That is called as a likelihood. Likelihood of the observed data is the product of the probabilities of all individual data points. That means we assume that the data points are independent and identically distributed. IID. This is the general assumption. This is the general assumption. The data points are independent of each other, and they are identically distributed. This we have to assume in case of logistic regression. Then the likelihood function L theta is given as the product of the probabilities. That means value of y multiplied by hx and 1 minus y. Okay, I guess this is to the power sign. What do you think? Is this a power sign? Hx to the power y multiplied by 1 minus hx to the power 1 minus y. What it is? It's a power sign.
Yes, sir.
Okay, so we need to discuss about this thing. Likelihood. The likelihood of the observed data is the product of the probabilities of individual data points. Product of the probabilities of individual data points. What does it mean? That likelihood of observed data is the product of individual data points. So we are taking the product here, and the product which we are taking is of the probability of hx and y multiplied by 1 minus hx to the power 1 minus y. That's what we are saying likelihood. Okay, and in the above statements also, I did talk about the likelihood here. Here, the cost function is typically defined as a negative log likelihood, also known as cross entropy loss of the model. Okay, so why this thing happen? Why this thing happen? What, what is your idea? What is your logic about it? That we are writing hx to the power y 1 minus hx to the power 1 minus y, multiplication of these two. That's what we are saying likelihood function. And then we came up with certain solution. Spontaneously we came up with some solution. So we need to consider this thing. Why this happened? We understood that, sir, if the output is y equal to 1, then we are going to have hx. If output is 0, we are going to have 1 minus hx. Then they are saying that you need to perform hx to the power y multiply by 1 minus hx to the power 1 minus y. That's what they are saying. This is called as likelihood. Okay, so we are talking about the probabilities and all these things right now. So, what, according to your understanding, is the likelihood for this, and how we get this formula?
Maybe we are taking collective probability of both
Okay,
hx and 1 minus hx.
okay, okay. Collective probability, fine. What about others? Because in general terms, if I pick up this word likelihood, it means that it means that everyone knows likelihood means happening of some event. Okay, what is the chance, what is the probability of happening of that event? So there might be a question which may come in your mind. That's why I keep focused on this particular line, hx to the power y and 1 minus hx to the power 1 minus y, and I told it as a likelihood. Why? Because the reason is the probability of an event is hx, okay, that means for success is hx, and for failure is 1 minus hx. Now we are talking about the likelihood, that means the chance that this thing is gonna happen. So to find the chance to this thing gonna happen now, we put this in particular format, that is hx to the power y minus 1 minus hx to the power 1 minus y, because these are the chances that it's going to happen. That's what your likelihood means. Okay, that's we call as a likelihood. Okay, so we are considering the probabilities. Okay, we are considering the probabilities, and after considering these probabilities, we are finding the likelihood of happening of an event. Okay, because it will let me know that success got this much time and the failure got this much time. This is the likelihood. And after getting the likelihood, obviously they told that you need to find the log to find the parameter theta that maximize the likelihood, maximum likelihood. That means we need to use the log function, log likelihood, logarithm of this likelihood, because it simplifies the calculations and does not change an optimal solution. So the log likelihood ll theta is given as log of this thing, and they did took a summation y into log of hx plus 1 minus multiply by log of 1 minus sx. So how you got this thing? Now again a question. If I do take a log of it, if I do take a log of it, how you got this result?
Yeah, we will take
As per
log
the
of it,
log,
and
Okay,
we
log of
will plus
likelihood
log of hx whole to the
equal,
power y
equal
plus log of.
so can I consider it will be like a log of a into b initially? Is that okay? Log a into b multiplication, log a
Yes,
into
yes.
log b. So what is log a into log b? What
log
is,
A plus log B.
okay, fine.
Log a plus log.
So log of a into b is equal to log a plus log b. Okay. So I'm going to have this thing, log of hx to the power y plus log of 1 minus hx to the power 1 minus y. This is the likelihood. And I guess log a to the power b is
Y
b log a. I think y will come in front.
b log a.
So log y
Yes,
into
yes.
log of h of x plus ये इधर I think it's हाँ, तो 1 minus y log of 1 minus hx. So here is a formula which I got. So when initially I told about this particular formula, when we were seeing, we were unaware of, sir, how we reached to this particular formula. And there are few more things they did mention. We got this result, we need to calculate the summation is for the cost function, because if I do consider this thing for a particular data point, then it will be a loss function. If I need to sum up this particular loss function, then I'm going to have a cost function. So we are initially talking about the cost function, not the loss function. Okay, so here what's the next statement told to us? The next statement is, the goal of the logistic regression is to find the parameters theta that minimize the log likelihood, that is equivalent to minimizing the negative log likelihood. Negative log likelihood. They took a negative log here. Okay, and here they use minus 1 upon m. As I already told, what is m? M is your data points. Okay, and rest of the equation is same, which we have calculated. So they told that to find the parameter theta and maximize the likelihood, you want to maximize the likelihood, that will be log likelihood, which is equivalent to the minimizing the log negative log likelihood. So if it is going to maximize, if there is a minus sign in front of it, so obviously its value will be down. Okay, see, remember, cost function, again, why they put a minus sign? See, cost function, if I'm going to calculate this thing, y log hx plus 1 minus y log of 1 minus hx, if its value is more, obviously you're going to have errors, isn't it? Errors. What is my goal? To reduce the error, है ना? To reduce the, if its value is more, that means the predicted and the actual predicted and actual difference is more. So they told that I need to, if as much as the cost function is, ultimately if I put a minus sign there, you see, -2 and -3, which one is lowest? Which one is lowest? Obviously -3 is lowest. However, this value 3 is in general greater than 2. Hana? But if I put a minus sign in front of it, it makes it down. Same thing they did mention here in their lines. The goal of the logistic regression is to find the parameter theta that maximize the log likelihood. Maximize the log likelihood. But if you want to minimize it, what we need to do? Put a minus sign in front of it. That's what they did. They put a minus sign in front of it. So j theta equal to -1 upon m multiply a summation of this log likelihood. This is how we achieved the cost function for logistic regression. Okay, so they did mention j theta as a cost function, m is the number of training examples, and theta represents the parameters. That means the weight and the bias of the logistic regression. Hx you very well know, these are the predicted probability. Okay, between 0 and 1. Okay, and we need to minimize the cost function during training, which will lead to finding the optimal solution. And the best fitting training data makes accurate predictions on the new data. That's what we need to do. Okay, so here we do have some more points to discuss over it. What it's saying? What are the else points to be covered here? It's telling that to train a logistic regression model, we need to typically compute the cost function on the training data. Okay, obviously we split our data into training, testing. We put the training data into our logistic regression, and then we do train it. Then we need to calculate the gradients with respect to the parameters. Obviously we did this thing same in case of linear regression also. We find the partial derivatives, okay, of m and your what, b. Okay, slope and the intercept, we perform partial derivative del by
M and B.
ha ha. Okay, so that we called as a weight and the bias. Same thing here also. That while during the training of logistic regression model, we need to compute the cost function on the training data. Okay, we are going to calculate the gradients with respect to the parameters. Whatever be the parameter, that is weight and the bias. These are the parameters. With these only, we need to calculate the derivatives. And then we need to optimize our algorithm by updating the parameters so that next time I'm going to get the less value of the cost function. That's what I need to do, and this process is repeated iteratively until the cost function converges to the minimum. That means converge ka matlab, that means unless and until I'm not going to get global minima. That's what the deal.
Global minimum.
Okay, I need to adjust my weight and the bias, or weight and the bias, that means my parameters. I need to perform the adjustments over it, and once I get adjustment, proper adjustments, when I'm going to get the global minima, I'm going to stop there. That's it. In that particular case, my error will be less. So you should be knowing each and everything. What is what is logistic regression, where it is used, how it's formed, what is the formula, what are the assumptions. You called it as a regression, you're using as a classification. Why? What are the drawbacks of linear regression? Okay. Then what is the cost function for logistic regression? Why it is not same as the linear regression? How to derive the cost function for logistic regression? Everything we should know. Okay, because it's mandatory to perform any of the project and using this technique. So in general, it's been applied over your classification problems 0 and 1. We took a case already of binary classification. Okay, so to solve logistic regression and find optimal set of parameters, that is the weight and the bias, we typically use optimization algorithms such as gradient descent. That means again we need to go down and we need to find the local minima, global, sorry. Okay, so how to do this task? First is your data preparation that we do. Ensure that our data is pre-processed, everything, missing value handling, everything, and then we split our data into training and the testing. Then we need to put our training data into the model. The point is, see, I have shown you the maths behind logistic regression. I need to implement this on Python also. We'll be implementing this code over Python. We're not going to directly import from sklearn dot linear model import logistic regression. No, as we did for linear regression, same we are going to do here for the logistic regression. And one more thing, there is a question, sir, it's a classification now, and you told us, sir, it will create a boundary, because in classification what happens, so where it is creating boundary, if I put a question, where it is creating boundary, where did you heard any point that it's creating boundary? You have seen the maths behind it, and your maths said that a logistic regression is going to find the probability, and I'm going to map those probability with the outcomes, that is actual values of y, that is 0 and 1. I need to perform the mapping. So where this boundary came into picture, because every classification model create a boundary, so where is the boundary, how, any suggestion from your side that boundary came, then only classification occurs. Because if I say my data points are distributed, okay, in this particular way, I need to make a boundary. So how this boundary came into the picture? We are looking forward for what, understand the theme of the algorithm, what it is doing. Unless and until without basic na, we can't do anything. For example, this is class and this is class B, we are going to perform the classification. Already you are mentioned with the classes 0 and 1. These are two classes present in your problem. Okay, these are the values of y, I need to classify it, and I need to properly classify it using logistic regression. So what I'm going to do in case of logistic regression, what I can do, I will say I'm going to consider the data points, and I'm going to calculate the probability probability of this data point, that we called it as hx. We called the probability of this thing as an hx. Okay, so and then what we are going to do with this probability, we are going to map with the actual output, that is 0 and 1, to which it belongs, whomsoever it is. If we say it belongs to 0, then obviously there's no role of 1, and if it is belongs to 1, then there is no role of 0. So we need to calculate the probabilities. So calculation of probability and mapping itself is creating your classification, it's helping us in creating a boundary. Okay, to where which point belongs, whether it's belong to class A, whether it's belong to class B. Also, every boundary do have some limit, no, limiting value. For example, if I say zero point 0.5 is the limiting value, every value which comes below zero point 0.5, it belongs to class 0. Okay, because it's going to give me the probability. So probability can be 0.9, probability can be 0.1. Okay, so I can get any kind of probabilities. 0.34, this is also probability is between 0 to 1. So I'm going to map these values, whatever with the probabilities which I am calculating, with the 0 and 1. Okay, with some limiting factor now, that's what I told. 0, for example, this is the bracket threshold, zero point 0.5. So below zero point 0.5 you are going to say, sir, it's belong to class 0, and above a zero point 0.5 or equal to zero point 0.5 you will say, sir, it belongs to class B or 1. That's what happening here in case of logistic regression. Okay, so how this task is being done now, on the basis of your adjustment of the weight and the bias. That's what they told. I need to reduce the error. So during training, I'm going to train my model. They are simply explaining you all these points. You are going to train your model. During training, you need to calculate the gradient descent. This is your cost function. You need to differentiate it with respect to the parameter, and it should be minimized. Losses should be minimized. How? What is the equation they given to us? They told that my cost function is this. Now you very well know how to derive this. Negative log likelihood. Negative log likelihood. This is your likelihood. This is your negative. Okay, so obviously you have taken the log. So it's a negative log likelihood. Okay, I need to calculate the gradient descent. So to calculate the gradient descent, ultimately to achieve global minima, to find the optimal parameter that minimize the cost function. The gradient descent is iterative optimization technique. Iteration, continuously it's going to work upon. So here is what we need to perform. Theta new equal to theta old minus learning rate into delta j theta old. Delta j theta old. So theta new is a parameter, weight. So this is new weight equal to old weight minus learning rate multiply by delta j theta old. That means your partial derivative with respect to del by del weight of j theta. That's what they are saying. So if you want me to rewrite this equation, what I will be writing? Okay, so you are having the parameters. Theta is their parameter. Okay, and obviously weight and the bias. Weight and the bias, these are the parameters. You very well know about this thing. What is weight and the bias? You have written the linear equation. What was the linear equation? Y equal to beta naught plus beta 1 x1 plus beta 2 x2. Okay, so what is your bias term? We are going to add na, we are going to add in case of linear regression, you know that in case of bias you are multiplying with 1. I hope if you remember, you multiply with 1. You multiply with 1. Do you remember what was the bias there? You multiply with 1 because this is beta naught. If I'm going to write it as beta naught x naught plus beta 1 x1 plus beta 2 x2, then only na it will be, then only y equal to beta x, then only it will be like na y equal to beta x, else how is going to get a beta x? Okay, so I need to multiply with the bias here. So in case of linear regression, we did took a bias as 1. Check out my previous lecture, and then during the derivation when I was explaining the concept also.
It's not. It's, X naught was one.
Yeah, x naught was, x naught was not
One.
there. Yes, x naught was
X
1.
X naught was there.
X naught was there.
Yes.
Okay, x naught was there.
X
So
naught was equal to one.
हाँ, that's what I'm saying ना, x naught तभी तो बोला ना इसको 1. I need to mention it कि इसको 1 करा. तो that is the additional feature. If you remember कि ये एक additional feature है. This is the additional feature which I have added. ये याद करिएगा आप. In your previous lecture, you can find it. There's one additional feature x naught which I made it all once. तभी जाके I'm going to get this complete equation. तो यही है. तो what is their cost function? They are saying cost function is j theta and it's minus 1 upon m, और ये पूरा likelihood है. I need to differentiate this j theta with respect to weight. क्योंकि आपके पास what are the parameters you are having? You are having the parameters as the theta, that is the weight and the bias. These are the parameters. Okay, so you need to adjust these terms. So del by j theta ये निकालना है आपको. Okay, और व्हाट इज द इक्वेशन फॉर द ग्रेडियंट डिसेंट? वो ये है कि जो नया वाला वेट है दैट इज डब्ल्यू डैश इज इक्वल टू डब्ल्यू माइनस लर्निंग रेट मल्टीप्लाई बाय डेल डब्ल्यू जे थीटा. ये इस इक्वेशन को आप बिल्कुल जस्ट कीप इट इन द मेमोरी बिकॉज मेनी टाइम्स वी आर गोइंग टू यूज दिस थिंग इन डीप लर्निंग. यहाँ तो चलो ठीक है. Okay, but in case of deep learning now it's totally based upon this thing only, क्योंकि there in deep learning ना वहाँ यही होता है, there is a adjustment of the weight and the bias. वो ऐसे ही होता है, ऐसे ही होता है. In case of deep learning we are going to find the gradient descent. वहाँ this thing is going to happen. Same equation. Okay, अब these terms are coming here also कि cost function you need to calculate and you need to adjust the cost function, or this is how you are going to perform the adjustments. That's what they are telling. Okay, so it's not a hard and fast thing. You are definitely understanding it practically, and that why we are doing this task, why we want to reduce The thing is, I want to minimize the error, then only now I'm going to get the good points. Else I can't get the good points. My model performance totally depends upon the cost function. If cost function is minimum, then only my errors are less. Then only I'm going to have a good behavior. Else I'm not going to have that. How to do this, sir? What we can adjust? Sir, we can adjust only the parameters. Else there is no chance to adjust any other thing. Okay, so how to do the adjustments? We are going to perform the partial differentiation that we have also did in case of linear regression also. Partial differentiation. Same thing happening here also. And who are the parameters there? So slope and the intercept. Here also same thing. Rest I don't have any parameter available. Rest I don't have any parameters available. Only this thing. These are the b naught, b1, and all these things. These are the parameters available. So that's why in case of logistic regression, you might have seen that along with the sigmoid function, they have also made a line in our initial diagram. This is your sigmoid function. You have seen, sir, this is a sigmoid function. Something it looks like S. This was my your sigmoid function. Okay, and they have also made a line along with that. This line. You can see my initial diagram of sigmoid. If you want, let me show you. Here it is. See, check out. This was the diagram of logistic regression. You can see a line because obviously na the sigmoid function comes from linear model. So I will be having a line also, and this is sigmoid. Okay, logit function. Okay, and we are talking about the probabilities p1 and p0, and we are solving for it only. So how we reached here? We started with p. We only started with p, which is the probability of of what? Of an event, either success, either failure. We did started with p. We used one more thing, 1 minus p. Then we calculated odds, है ना, ratio of these two. We calculated log. We equated this thing to the line, and we got the value of p as 1 upon 1 plus e ki power minus theta x. This is what we got. Later on, after getting this thing, we have been told, sir, this is a probability. Let me call this as hx. Let me call it as hx. And then you have been asked, sir, if you are tackling with a binary problem, so for binary problem you are having y as 0 and y as 1. So if it is 0, let us say its probability of hx, then for 1 its probability 1 minus hx. Quite clear. And then you have been told, sir, kindly calculate the likelihood. So for likelihood you have been considered that hx to be multiplied by y, not y multiplied, it should be to the power. Okay, for likelihood you should be making hx to the power y multiply by 1 minus hx to the power 1 minus y. That's the likelihood. Then you calculated the log to have a log likelihood. We need to calculate the log. And while calculating the log, you got this thing, something y log of hx and plus this thing. And then you put a minus sign in front of it to reduce the cost function by 1 multiply by 1 by m also. Because I need to calculate the cost function, m is then all the number of data points. If I don't do this thing, then it will be a loss function for a single data point. For a single data, what's the loss? I need to calculate the for all the data points, then it will be cost function. So we done up with this thing here. Then they told, okay, you need to adjust the weight and the bias. You need to adjust the parameters here. So how to adjust the parameter? There is a generalized equation for adjustments of the parameter. What is the generalized equation? Sir, weight new is equal to weight old minus alpha, that is a learning rate, and learning rate we have already discussed in the previous class also. It is a step size. That means you are, that means what step size means? See, you are available with some data point. You do start with some data point, and you need to go down. You need to go down. You need to take the steps down, and you need to reach the global minima. Global minima. So you need to start with at some point, and getting down, for example, jumping to this point, jumping to this point, jumping to this is called as a step size. Okay, so you need to take certain steps, and this step size is called as alpha learning rate. Okay, we never consider high learning rate, else it will be problematic. Neither very very low. Okay, we can consider low. Okay, we do consider learning rate as 0.001, sometimes 0.0001 also. These are the learning rates, these are the step size by the help of which you can go down, down, and get try to find what is the global minimum. This is what we do in case of deep learning also. Same concept is applicable when I'm going to talk about the optimizers. We need to optimize our this, okay, problem statement optimization of our model that we do in case of your deep learning. Same thing, I need to find the global minima. Here also they are saying the same point they are focusing. So W weight is given by such formula. Learning. So here you, if you question me, sir, how to get a learning rate? What should be the value of learning? In question, you will be available that your learning rate is this, and come on, and your initial weight and the bias are, for example, zero. Initial are these things. Now calculate for this much iterations. For example, 10 iterations. What is the value? What is the value of the weight and the bias? You have been given in the problem statement. You need to solve. You need to apply this formula. So we did perform this partial derivative in previous for linear regression also. Here same thing is applicable for logistic regression. You need to calculate the partial derivatives for the adjustments. Okay, and on the basis of partial derivative only, now we got those values of slope and intercept. Okay, because in that particular case, in case of linear regression, if you remember, we were talking about mean square error. Mean square error, summation of yp minus y actual, है ना, का square का मतलब this is the overall mean n. And what we did, we calculated derivative of this particular thing. तो यहाँ भी ना आपका डेरिवेटिव यू नीड टू कैलकुलेट ना, डेल बाय डेल डब्ल्यू, डेरिवेटिव तो लेना है ना. वी नीड टू डेल किसका डेरिवेटिव, माइनस वन अपॉन एम समीशन ऑफ वाई लॉग ऑफ एच एक्स प्लस वन माइनस, हाँ यही है, हाँ वन माइनस वाई लॉग ऑफ वन माइनस एच एक्स, इसी का तो डेरिवेटिव लेना है. दैट्स व्हाट यू नीड टू परफॉर्म. अब अच्छा, ये ना द थिंग इज कॉम्प्लिकेटेड हो जाएगा अपने लेवल पे अभी. क्यों? क्योंकि यू नीड टू रिप्लेस एच एक्स. एच एक्स को किससे रिप्लेस करोगे? विद whom you are going to replace hx? Hx will be replaced by whom? Will be 1 upon 1 plus e की पावर माइनस थीटा एक्स, इससे रिप्लेस होगा वो. और थीटा में, थीटा ही तो है भाई ये पैरामीटर w, इसी में ही तो वो w है, वेट है. तो वेट भी है और बायस भी है यहाँ पर. यू आर गोइंग टू हैव बोथ ऑफ थिंग इन योर दिस थीटा, सब मिल जाएगा आपको. तो अब आप बोलोगे सर वो डेरिवेटिव हाउ हाउ टू कैलकुलेट. तो ये तो अब इतना मैथ्स अपन को जाना नहीं. इफ ऐसे कि यू नीड टू कैलकुलेट द डी बाय डी, डी डब्ल्यू निकालना है, एंड यू आर अवेलेबल विद 1 अपॉन 1 प्लस ई की पावर माइनस थीटा. अब थीटा हाउ आई कैन राइट द थीटा, how I can write the theta. तो theta में तो weight and bias दोनों है, तो bias will behave constant here. When I'm going to differentiate with W, weight का ही parameter है, and bias will going to behave as a constant. Okay, तो if I'm going to have like ऐसा बोलते हैं हम, weight ठीक है, m ले लिया, तो W x प्लस b, फॉर एग्जाम्पल बहुत ही सिंपल चल रहा हूँ ऐसा. तो अच्छा, ये है सिग्मोइड एच एक्स, और उसके आगे लगा है लॉग, ये भी लगा हुआ. इफ यू कंसिडर द सिचुएशन, इतना कोई बताता नहीं, इतना कोई डेप्थ में जाते नहीं. वो तो मेरे सामने द इक्वेशन आई एम गोइंग टू सी ना, दैट्स व्हाई आपको बोल रहा हूं मैं. तो ये है लॉग, ये हो जाएगा क्या, डेरिवेटिव ऑफ डी बाई डेल डब्ल्यू, लॉग ऑफ एच एक्स का डेरिवेटिव है। ठीक, ये इस इक्वेशन में, इन दिस पर्टिकुलर इक्वेशन हमको ये जाना है अंदर, उसको डेरिवेटिव लेते हुए माइनस वन बाय एम तो कांस्टेंट है, इट विल कम आउटसाइड, एंड आई एम गोइंग टू कैलकुलेट द डेरिवेटिव ऑफ वाई। वाई, अच्छा वाई भी कांस्टेंट रहेगा तो वाई भी बाहर आ गया, इसका लेना पड़ेगा, लॉग ऑफ एच एक्स का डेरिवेटिव लेना है, प्लस वन माइनस वाई भी बाहर आ गया, अगेन एंड आई नीड टू कैलकुलेट द डेरिवेटिव लॉग ऑफ वन माइनस एच एक्स, ये लेना पड़ेंगे इनके डेरिवेटिव। ओके, तो फिर उसका नया वेट आपको मिलेगा, न्यू वेट, एंड देन बस फिर अपन अगेन वी आर गोइंग टू पुट गो अहेड फॉर द नेक्स्ट इटरेशन, देन अगेन वी आर गोइंग टू एडजस्ट अवर वेट्स। ऐसे वेट चलता रहेगा अनलेस एंड अनटिल ग्लोबल मिनिमा ना मिल जाए, दिस विल कंटिन्यू अनलेस एंड अनटिल यू आर नॉट गोइंग टू अचीव द ग्लोबल मिनिमा, ये होता है पीछे, दिस इज व्हाट हैपेंस, okay, in case of logistic regression. So cost function is different, accordingly the calculation will also be different for the cost, for your logistic regression. Okay, तो ये detailed discussion needs to be done over the logistic regression की sir how we achieve this cost function. Okay, तो ये आपका doubt the previous class का was there, so I thought कि in this particular class I am going to derive you how I achieve the cost function. Okay, so after the cost function that you have derived कि ऐसा ऐसा होता है, this is your cost function term. Now I hope you will not forget minus log of h theta x minus 1 minus log of 1 minus, this is your cost function. Okay, so if your y is 1, if you put y is 1 you are going to get this thing, if you put y as 0 you are going to get this thing, बस ये मिल जाएगा आपको. Okay, it's already mentioned here. ओके तो अब ये बोला गया कि यू माइट बी वंडरिंग व्हाई देयर इज अ नेगेटिव साइन इन द कॉस्ट फंक्शन, तो आई ऑलरेडी टोल्ड कि कॉस्ट को तो नीचे गिराना ही है, we need to dip down the cost. Okay, and we can see the values present in the log will be the probability between 0 and 1, ये तो मिलना है. In case of logs, यहाँ log ले रहे हैं, and hx is obviously what, hx क्या देने वाला है तुम्हें, what hx is going to do, ये probability तो है, ये p है, ये it's p, it's probability. और यहीं से शुरुआत करी थी लॉजिस्टिक की, वी डिड स्टार्टेड फ्रॉम लॉजिस्टिक ऑन द बेसिस ऑफ दिस प्रोबेबिलिटी ओनली पी, तो ये पी तो है, ये एच एक्स, ये पी है, तो आई एम गोइंग टू गेट द प्रोबेबिलिटीज between 0 to 1, so the value of log 1 is 0 and log 0 is negative infinity, ऐसा बोला. log 0 क्या होता भाई, log 0 क्या होगा, व्हाट इज log 0, ये तो कभी पढ़ा ही नहीं है इतना कुछ. log 0, log 1 0 होता है, log 0, तो ये बोल रहा है log 0 इज नेगेटिव इन्फिनिटी, ये होता है. उसी चक्कर में इन्होंने यहां पटक दिया नेगेटिव. So the values from the cos function will always be in negative terms. That is why we add negative sign to it. तभी इस चक्कर में हो गया वो नेगेटिव. ओके, और एक जनरल वी हैव टॉक्ड अबाउट कि मुझे कॉस फंक्शन आई एम गोइंग टू हैव, मतलब ये कि टू मिनिमाइज इट आई नीड टू पुट अ माइनस साइन आउटसाइड. So I'm going to get the probabilities here between 0 to 1 probability I'm going to achieve, and for log 0 it's been negative. ओके, इट मे हैपन कि कभी ये प्रोबेबिलिटी जीरो आ गई. ओके, तो उसका लॉग इफ आई एम गोइंग टू कैलकुलेट तो वो आपका क्या हो जाएगा, नेगेटिव हो जाएगा. तभी इन्होंने इन जनरल केस दे पुट अ माइनस साइन ऑल्सो, बाहर कर दिया उन्होंने. तो ये आपको एक्सप्लेनेशन पता होना चाहिए क्यों लगाया, व्हाई द कॉस्ट फंक्शन इज नेगेटिव. तो हम अभी तक सो फार वी नो अबाउट लॉजिस्टिक रिग्रेशन. हाँ सर, इंपोर्ट फ्रॉम लीनियर मॉडल और ये, एंड पुट द वैल्यू इनसाइड इट एंड एक्स ट्रेन वाई ट्रेन, एंड सर ये रहा. तो पहले unless and until we don't know the assumption, so I request you all, okay, I request you all ki whatever be the points, don't write, but at least you should whatever be the notes available with you, just copy paste कि linear regression these are the assumptions, just assumptions यदि आप याद रख लें तो आप कर जाओगे क्वेश्चन सॉल्व. ओके, बिकॉज इतना इन डेप्थ नॉट एवरी वन आस्क, बट आप इफ योर कोर्स एस्पिरेंट तो आपको तो पता होना चाहिए डेरिवेशन. ओके, तो ये कॉस्ट फंक्शन एंड ये आया कहाँ से, समवन एज ये लीनियर रिग्रेशन आया कहाँ से, तो और ये लॉजिस्टिक रिग्रेशन वेयर फ्रॉम वेयर इट केम, सो यू मस्ट बी नोइंग दिस थिंग्स. ओके, तभी आपके लिए ये पूरा ये तैयार किया जा रहा है. ओके, तो ये आपको पता होना चाहिए। बाकी अजम्पशंस इंपॉर्टेंट है वाइल डूइंग डूइंग द प्रोजेक्ट, क्योंकि यू नीड टू फोकस अपॉन द डेटा, यू नीड टू फोकस अपॉन द डेटा। और अब मैं डेटा की तो क्या बात बोलूं, डेटा इतना गंदा आता है, मतलब ये है कि इट्स नॉट बीन, मतलब कुछ भी आपको दे दिया, बोला चलो परफॉर्म करके बता दो। Okay, do the task. Okay, so for example, if I talk you about a data set, talk you about a data set. अच्छा, इसमें कोई questions पूछना है क्या? You do you want to ask any questions over it? Why negative? How we got this for this particular thing? Gradient descent I've already told. Optimization technique है ये, optimization algorithm. We need to perform this gradient descent because I need to adjust the weight and the bias. ये मुझे करना है, तो मुझे differentiate I need to do, मुझे कॉस्ट फंक्शन का डिफरेंशिएशन करना पड़ेगा विद रिस्पेक्ट टू दीज पैरामीटर्स थीटा। इट्स व्हाट वी डू। ओके, सो ग्रेड एंड डिसेंट कॉन्सेप्ट, तो ये तो आपका सिग्मोइड फंक्शन रहा, ये आपका एक्स की वैल्यू एक्स इक्वल टू बी नॉट प्लस बी वन एक्स ये रहा। ओके, एंड बस ये लर्निंग रेट रहा अल्फा, कुछ भी ले लो, 0.01 या 0.001 समथिंग वेरी स्मॉल वी कैन टेक, ये स्टेप साइज होती है टू रीच द ग्लोबल मिनिमा। ओके, और ये रहा आपका क्या, gradient descent, पार्शियल डेरिवेटिव, समीशन ऑफ एच थीटा माइनस वाई आई एक्स आई, ऐसा बोल दिया उसको, डेल अपॉन जे थीटा इज इक्वल टू समथिंग लाइक दिस। दिस इज हाउ वी आर गोइंग टू कैलकुलेट द कॉस्ट फंक्शन इज, अच्छा क्या बोला, कैलकुलेशन इक्वेशन अचीव्ड इज दिस थिंग, डेल अपॉन डेल जे थीटा, ऐसा बोला गया। ओके, वी नीड टू अपडेट द वेट विद द हेल्प ऑफ फॉलोइंग इक्वेशन। या ये रहा, ये तो मैंने आपको बता ही दिया, वी नीड टू कैलकुलेट द वेट। तो ये आपका दिस इज योर न्यू वेट, दिस इज योर ओल्ड वेट, ऐसा करके कर सकते हैं। तो ये अच्छा, अलग अलग नोट्स में अलग अलग टर्मिनोलॉजी है, डोंट गेट कंफ्यूज। ओके, बस सिंपल सी टर्मिनोलॉजी वही थी, डब्ल्यू डैश इक्वल टू डब्ल्यू माइनस अल्फा एंड डेल बाय डेल 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 डब्ल्यू ऑफ जे थीटा। दिस इज सिंपल टर्मिनोलॉजी, फ्रॉम हियर यू विल अंडरस्टैंड कि वेट कैसे कैसे आपके एडजस्ट होंगे। ओके, तो अलग अलग नोट्स में अलग अलग टर्मिनोलॉजी, डोंट गेट कंफ्यूज ओवर इट। now you want to say something over the cost function, something about gradient descent, y negative, why, how we achieved this formula. Now tell me please, any doubt over it? You must be thorough with all the concepts. Okay, and means daily revision and some working over the quotes projects will help you a lot. Okay, for any doubt you can ping me, ask me. Okay, so let me stop the recording here.